Welcome to the course Business Analytics and Data Mining Modeling using R Part 2. So, in the previous lecture we were discussing association rules, specifically we were talking about the transaction data formats. So, we discussed item list format and also binary matrix format. So, we also in RStudio we also went through an example how these two formats are different from each other. So, we discussed all those details and did an exercise in RStudio as well. So, let us move forward. Now, as we have completed our discussion on the rule generation stage and also the assessment of rule strength. So, next important step is the rule selection. So, once the assessment of rule strength has been done, now how do we select the rules for implementation. So, as you can see here, we can select the rules which have confidence value higher than the user specified cutoff value for confidence. So, again here also we require a certain input from user for selecting the rules, association rules. So, any rule which is having higher confidence value, higher value than user specified confidence level. So, those rules can be selected. So, let us open RStudio and go through an exercise to understand this further. So, in the previous lecture we were able to create this binary matrix format in the particular fashion that we wanted, particular configuration that we wanted. Few more things that would be of use later on. For example, we can convert these transactions to transaction ID list. So, for that we can use this particular again as function, and you can see IL1 that particular variable is being used, and then we can have this TID transaction ID list TID list as the format, and let us run this. If we run this code, you can see this is the format. So, this is transaction ID list format. So, here you can see the items, all distinct items are arranged in each row. So, we have 6 distinct items. So, we have 6 rows: red, white, blue, orange, green and yellow, and for each of these items the transaction IDs where these items are occurring. So, for example, first row we have red item red, and the transaction IDs where this particular item is present. So, you can see transaction ID 1, 4, 5, 8, 9. Similarly, white is the most frequent item here. See, it is out of all 10 transactions, 8 transactions it is present. Similarly, for blue, orange, green and yellow, we can see the transaction IDs where these particular items are present. So, this is the transaction ID list format. Let us move forward. So, now what we can do is we can create so earlier the matrix that we had created, the binary matrix format that we had created, it was logical. So, we had true and false to indicate whether a particular item is present in a particular row, that means a particular transaction. So, we can change this a bit. For example, we can make it this instead of using true false value, we can start using 0 and 1. So, for that you can see that we are using apply function, and the function that we are going to apply here is as dot numeric. So, all the logical values are now going to be coerced into numeric values. So, true and false are going to be converted into zeros and ones. So, let us run this code. Now, at the same time we will also like to change the dimensions here. So, these dimensions that we had created earlier that we are going to use. Now, let us look at the this format. So, now you can see that all the values, all the cells are being indicated as 1 or 0. So, if that particular item is present in that particular transaction, so it is 1, otherwise it is 0. If it is absent, then it is 0. So, you can see the item labels are also just like we created in the last lecture, red, white, blue in that particular order, and we have total 10 transactions. So, now this format that we have just created, now this is binary matrix format, and the values are also being indicated using ones and zeros. If we want to identify item sets which are having support or count value greater than or equal to 2, we can do so using this particular function ECLAT. So, we are interested in finding more details about ECLAT, what it does. So, it is actually it will be able to help us in creating the rules using that particular transaction data set. So, let us look at the more details about this particular function. So, ECLAT, as you can see here. So, this particular function. So, you can see the description, mine frequent item sets with the ECLAT algorithm. This algorithm uses simple intersection operations for equivalence class clustering along with bottom up lattice traversal. So, essentially this particular algorithm can be used to mine frequent item sets. So, this is the function that we are going to use here. So, let us run this code. So, other arguments of this code, if you see that we are passing the IL1, which is the the item list format that we have, matrix format that we binary matrix format that we have, then you can see we have specified the support as 0.2, right, because we want the we want to identify all the item sets having support greater than 2, and other parameters are also specified. So, let us run this. Once this is done, we can use the inspect function to analyze see the results. So, you can see here we have the list now. So, all the item sets which are having support greater than 0.2, you can see here support and count 0.3, 0.2 in this fashion. We are able to see. So, all the sets which are having which are having support or count value greater than this can be seen here. Now, if we want to arrange this list in the order of count, in the order of support, so we can do this. So, you can see this code, if we run this, we will get the list as per the order. So, you can see white is the most frequent item set. So, this single item, this is coming 8 times, this is present in the database, then red 5 times, then blue 5 times. In this fashion, you can see the database is presented here. Now, this particular ordering is, if you look at this particular ordering, is based on the size of item sets. So, the first the item sets having just single item are coming first, then followed by the item sets which are having 2 item sets, and then 3 and 4th. Now, if we want to run a priori algorithm here, so we have this a priori function. So, we want to mine the frequent item sets, we can use this particular function. A priori we are passing IL1, this binary matrix format. You can see the parameter support is specified as 0.2 and the confidence is specified as 0.7. So, the user specified minimum support level is 20% and the user specified minimum confidence level is 70%. So, we can use the a priori function, and we can pass on the first argument being the matrix, and then the support and confidence value. So, we will get the association rules here. So, let us run this. Now, let us sort these rules also by their lift value. So, after this sorting, we would like to see. So, let us inspect the sorted rules. So, now you can see 8 rules are there, and you can see they have been ordered with the lift values. So, first rule, green. If if the green is green colored mobile cover is purchased, then red color mobile cover is also purchased. So, this is having the highest lift value of 2. Then the second association rules, where if the white and green mobile covers are purchased, then red is also purchased. So, this particular association rule is also having the lift value of 2. So, similarly we can look at others. So, you can see here all the association rules which are having greater than 1 lift value, they have been shown here. So, as we talked about, for our a particular association rules to be useful, it should have a lift value of greater than 1, right. There are few other functions which can be used if we are just interested in looking at the matrix number, then quality function can be used. Then few more details if we are interested, we can look at the summary function. So, we would be able to see few more details. For example, if we just look at a few more details here, you can see set of 8 rules, rule length, distribution, sizes, LHS plus RHS is given there in the summary output. Then we can look at these quantiles values, mean, median, first quantile, third quantile, all those values are also there. Then the summary of quality measures are also there. Then it might so happen that some of these rules might be subset of some other rules. So, we can always eliminate these subset rules. So, redundant rules can be identified and they can be removed from the output, and then we will have just the rules which are redundant rules are removed and we have just the meaningful rules. So, no repetition. So, this is the code that can be used. You can see we are using is dot subset function. So, this function is being used to identify, to spot the rules which are subset of some other rules, right. So, once this is done, you can see, because this output is going to be a matrix, and then this is going to be a lower triangle we are terming as NA, so that the repetition is allowed, repetition is avoided, and then we are summing all these cells. So, if the sum is greater than 1, then probably that particular rule is subset to more than one rule. So, therefore, it has to be removed. So, let us run this code. So, if a particular, so you can see the output as well. So, this is the matrix, and if a particular rule is subset of any other rule, so it will have the finally when we sum that up, it will have the value equal to or greater than 1. So, let us compute these values. So, now which of these rules you can see. So, these are some of the subsets, these are some of the item sets which are true, indicating that these are subsets to some other rules, right. So, we can find out the indices of these rules, you can see here, and then we can prune them. So, we will just have to remove these rules, and we will be left with remaining rules. So, in this fashion we can create rules and identify and eliminate any redundant rules if there are any. Let us come back to our discussion here. So, how do we interpret the results, the exercise that we have just completed in our studio? How do we interpret some of these results? So, first let us start with the support. So, support of a rule indicates its impact with respect to database. So, what proportion of transaction is affected. So, that is the sense that we get by support of a rule. If higher the support, that means in the impact of that particular rule is higher, and we will also get the idea about the proportion of transactions that are being affected by a particular rules. So, higher support is always preferable for the business and operational purposes. If we look at the lift ratio, then the lift ratio indicates the efficiency of a rule in finding consequence in comparison to random selection. So, if the lift ratio value is higher, then of course that rule would be considered to be more efficient in terms of finding the consequence. So, whenever antecedent is present, it is more likely that consequent is also going to be present. So, that efficiency of a particular rule is going to be indicated or captured by lift ratio. So, we would always like to go for association rules which is having higher lift ratio. Now, we look at the confidence metric. So, this particular metric indicates the rate of finding consequence. So, as we understood from the formula itself, so out of all the transactions where antecedent item set is present, what is the proportion of item set where the consequent is going to be present as well. So, in a sense we are getting the rate of finding the consequence. So, in this fashion for a particular rule, so always if the value of confidence is higher, then probably the rate of finding consequent is higher. So, we would like to prefer a rule which is having higher support value, higher confidence value and higher lift ratio. Now, there is always question mark on data mining techniques because of them being data driven model and a lack of statistical inference. So, whether all these rules that we are trying to generate through an automated method, whether they have some statistical significance, or how do we ensure that they are not out of just chance occurrence. So, this is always going to be a question mark on this. So, how sure are we about the meaningfulness of these rules? So, are we ending up with associations which are just chance occurrences? So, how do we clear some of these questions? So, that is also important. So, let us open RStudio and we will try to understand this particular aspect through an exercise. So, what we will do, we will create a randomly generated data and we will mine that data and see whether there are any meaningful associations that are coming out of this randomly generated data. So, since the data has been generated randomly and still if we are able to identify certain rules which are having high confidence, high support and high lift ratio value, then the chance occurrence is a serious problem in that case. So, let us go through an exercise. So, you can see here chance occurrences, whether a particular association rules can fall into this trap, chance occurrences trap, because of it being a data driven process. So, in this case we are trying to randomly generate this data. The number of items that we are going to consider is 9. So, these are the distinct number of items are 9 and the number of transactions that we are going to generate are 50. So, the function that we are going to use is random.transaction. So, this function random.transactions will create these 50 transactions using 9 distinct items. So, you can see the first argument is number of items, that is 9, then the number of transactions, that is 50. Method you can see is independent, because we want this to be a randomly generated data, no inbuilt association between these transactions, right. So, probability value we are giving equal probability value for all of these items. So, you can see 1 by 9 is the probability value for all these items. So, they have equal chance of occurrence, these items have equal chance of occurrence. So, let us run this code. More details about this particular function random.transactions, you can always visit the help section and find out. So, once this is done, let us look at let us inspect the database. So, you can see 50 transactions here. Now, let us scroll. Now, you can see we have the items. So, each transaction, each row is representing a transaction, and first we have the items that are part of that transactions. So, first transaction we have just the item 4 and transaction ID is trans 1. Then the second transaction we have these items, item 3, item 5, 7, and the transaction ID is transaction 2. You can see that all these 50 transactions, different items have been randomly selected depending on the parameters that we have passed. So, these are the randomly generated transactions. Now, what we will do is we will go about applying association rules mining using this particular database and find out whether chance occurrence has a role in this process or not. So, another thing that we might be interested in, size of these transactions. So, you can see for each transaction number of items that are present in each of those transactions, that can also be seen through this output. However, right now we are more interested in doing this association rules mining. So, we will run this a priori, we will call this a priori function, and use this randomly generated database. And the parameter, as you can see, we are specifying the minimum support as 4%, 0.04, and the minimum confidence as 70%. So, we are keeping the support as quite low value, so that the more number of rules are identified, and the confidence is 70%. So, let us run this code. Now, let us inspect first 9 rules. So, you can see here we are just looking at first 9 rules. So, let us scroll and see. So, as you can see here that the first rule that has been selected is where the if item 4 and item 8 are purchased, then item 1 is also purchased. The lift value of this particular rule is 2.5. So, even though this whole data was randomly generated, and then we applied association rules mining on this database, still we are able to find out some very strong associations. Item 4, item 8, item 1. So, this particular transaction we did not had any inbuilt association. This was randomly generated, these were randomly generated transactions, and still we are able to identify certain association rules. For example, rule number 1, 2, 3, 4, 5 all are having there are a number of rules, as we can see in this output, which are having lift value greater than 1.5. 2 rules are having lift value greater than 2, 1 is having lift value of 2.5. So, some strong associations are being identified even in this randomly generated data. So, this is a cause of concern. So, how do we overcome this? So, association rules mining, the rules that we get, the rules that are having higher support, rules that are having higher confidence value and higher lift value, whether they are meaningful or not, whether they are useful or not, how do we find out. So, let us discuss more about this. So, how do we assess rules for spuriousness due to chance effects? So, two points that we are going to discuss here. So, if you look at the example that we have just gone through, the support level that we have kept there was quite low, right. So, if we are able to have for a particular rule, if there are more number of transactions that are supporting a particular rule, then there is less chance for spuriousness. So, if there are, let us say 1000 transactions, and if there are a number of transactions, let us say 100 or more than 100 are supporting a particular rule, then there are less chance of spuriousness. If we go back and look at the results that we had, if we see that the first rule that had the lift value of 2.5 and the confidence value of 75%, but it had just the 6% of support, right. So, it has a low support. So, number of transaction out of the 50 that we had, so number of transaction would be quite few, just about 3 transactions. So, if more number of transactions are supporting a particular rule, then we might be able to eliminate this chance of spuriousness. So, the rule of thumb could be have the select those rules which are having a large number of transactions supporting it. So, large number of transaction yield margins of error to a small range occurring due to sampling variations. So, if there are a large number of transaction involved behind the rule, then the margin of error that would be to a small range, right. So, the rule is going to be more meaningful, more useful. Of course, we can always look for statistical confidence intervals on proportion to look at the margin of error, right. So, this is one. The second point that we are discussing here is that if there are more number of distinct rules, then there is higher chance of spuriousness. So, if we are going with if we are going with we look at our business and operational capabilities, and if we are going with a number of a higher number of distinct rules, then there is more chance that that this particular spuriousness is going to occur. So, how do we overcome this problem? So, what we can do is we can limit the number of rules that can be considered from the top down. So, in the sorted list, using the lift ratio. So, from that list, from the top down in fashion, we can limit the number of rules that are to be considered for implementation depending on what can be reasonably incorporated in a human decision making process. So, all this is to guard against the automated review of rules that we have. So, in this data driven modeling process, we are always going to generate a number of rules. This whole process, association rules mining, is always going to generate a large number of rules. So, we can restrict ourselves depending on what we can accommodate in our human decision making process, and just consider the top top rules, right. So, in this fashion we would be able to control this problem of spuriousness. What we can look at right now is a database which is, again, this particular database is also manufactured, but this particular database is based on a real manufacturer, based on a real life situation. So, for this is Georgia cafe.xlsx file that we have. So, this data set is about customers purchasing different items from a cafe. So, let us look at this database. So, we will go through all this whatever we have discussed till now, the association rule mining process. We will go through this process using this particular data set. So, let us load this library. So, this particular library is right now not installed. So, let us install this. Double quotes. Let us use the name of this package. Now, once this package is installed, so we would be able to load this particular this particular function. We would be able to load this library xlsx, and then we will have a look at this particular data set that we are talking about. So, as I talked about this particular data set Georgia Cafe, this is about the customers, transactions of customers purchasing certain food items, other snacks, and other items, beverage items from this cafe, and each transaction is going to represent the items that are going to be that have been purchased by that particular customers, and we are going to use. So, this is this data set is even though this is manufactured, this is representing a real situation, real life situation. So, we will try to understand this data set and then mine. So, whether which items are, we will try to mine these data sets, these transactions, and find out which items are being purchased together. So, once this package is installed, so it is about to get installed. Once this is installed, we will load this library and import this data set. So, we can see so this package installed. So, let us load the library. So, there is one more package that we need to install. So, because there are so many packages that are involved in while we do our modeling in R. So, sometimes we will have to install all these packages on the go and load them. So, we need to install this R Java package. Since you can see there was an error, so we need to install this. So, looks like now this time we will be able to load package we are not able to install. So, we will stop here. In the next lecture we will have this particular data set loaded, imported, in the RStudio environment, and then we will do our mining using this particular data set. Thank you.